Origami is the ancient art of Japanese paper folding. For years, it has been used to create stunning works of art. But origami has also been used in more surprising ways, like car airbags, stents, and even space exploration.
What we want in space are large structures, not necessarily massive, but large, which means you can make them out of thin materials. And wherever you can make them out of thin materials, you can use origami to fit them in these rockets.
Many space projects have used the folding principles of origami. The solar array wings on the ISS use a Z folding pattern, and the Mars Phoenix lander used a fan-folding solar array called the Ultraflex.
Because the biggest rockets we have right now are only about 5 meters in diameter, we have to come up with a way of folding up this very large structure into spaces that we can launch it inside a rocket. And once it gets to space, it can unfold itself. And origami is one mechanism by which we can do that because it gives us the underlying mathematics of how large, thin sheets fold up.
One origami project currently in development at NASA's Jet Propulsion Lab is the Star Shade, which is essentially a big star blocker. Have you ever tried to take a picture of someone when the bright sun is beating down on them? All the detail gets washed out. This is the same problem astronomers have when trying to image exoplanets. Currently, astronomers detect exoplanets indirectly using a shadow technique called the transit method. For an Earth-sized exoplanet orbiting a sun-like star, they can't be imaged in detail because the stars they circle are much brighter than they are. This is where the star shade comes in, to help block that bright light to better help astronomers learn more about these mysterious planets and look for biosignatures for life.
One of the ways in which we're thinking about suppressing the starlight is using something called star shade, which is a very large external occulter that flies in front of a space telescope and blocks out that starlight so you can image that really faint planet right next to it.
Sounds easy enough, but the star shade is roughly the size of a baseball diamond.
Because the star shade is so huge, we have to come up with a way of folding up this very large structure into spaces that we can launch it inside a rocket. And once it gets to space, it can unfold itself.
Which is where origami comes in.
So this is one of the candidate fold patterns that we had for the inner part of the star shade, what we call the optical shield. It's got a very deterministic shape when it's folded up, so we designed it to have this shape in which it can account for the thickness of that blanket. You can mathematically define how this sheet of paper is folded up. And the way it unfolds is like that it creates these very nice spirals inside the folded structure. It's quite remarkable in its simplicity.
This giant space flower may seem simple in design, but not in implementation. The star shade will need to unfold with millimeter accuracy. Once opened, thrusters will move the craft through space, positioning the star shade between the star and the space telescope. With the star now being shaded, the telescope can image the planet in detail to find out whether conditions for life exist. Origami has been practiced on Earth for years, and scientists will continue to draw inspiration from it to help package big space structures more efficiently, from solar sails that use sunlight for propulsion to sunshades for telescopes like Gaia and the James Webb once it launches in 2019.
We can take these ideas from origami and apply them to spacecraft structures that way.
Because when it comes to the future of space exploration, if we want to think big, we also have to think small. For more science documentaries, check out this one right here. Don't forget to subscribe and keep coming back to Seeker for more videos.